Well, hey guys, welcome to the statistics test and solutions. So what I want you guys to do is I just want you guys to correct the ones you missed and write a sentence why you missed it. And hopefully this solutions video will get you going in the right direction. Okay? And then you get half the points back. So you can make half your points back by making your corrections. All right. So number one is the mean. And your mean was, let me do that in a different color here. Your mean was 4.7. And all you simply do to find the mean is this student right here, put them in order. That's probably a good strategy right off the bat, is to order your data from least to greatest. And you just simply add them up and divide them. And I think this case there was 12 pieces of data, if I remember right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You'll divide by 12 and get 4.7. The mode is the number that occurs the most. We can see that there's by far, well, not by far, but there's 3 2s. So your mode is 2. All right, this is where some of you started going south, is on your 5-number summary. Remember, the mean is not included in your 5-number summary. Okay, so the minimum value, let me erase this highlighted part here. Your minimum value was 2. So that's your minimum right here. Your maximum value was 10. So that's your maximum value right here. Now, Q1 is basically, before you find Q1, you need to find Q2. So to find Q2, it's right here. It's halfway in between these two 4s because there's 12 pieces of data. Therefore, you're going to have a middle. So it's not either one of these 4s that are circled right here. It's another 4 in the middle. So it's your median. Your Q2 is 4. Your Q2 is 4. So you want to find your Q2 before you find your Q1 and Q3. Now to find your Q1, you just go halfway in between. So right here, you can see halfway in between is 2 and 3, and halfway between 2 and 3, you can either add them up and divide them by 2, or just know that 2.5 is halfway between 2 and 3. And then again, to find your Q3 is down here. Halfway between 6 and 7 is 6.5. And that's it. Now, the next thing you want to do is find your IQR. Your IQR, let me erase this again. Your IQR is simply just your, go back through and erase this. Your IQR is simply just your Q3, and I think we've talked about this, which is 6.5 minus Q1, which is 2.5. And 6.5 minus 2.5 is 4. So that is your IQR. Are there any outliers? Well, no, there's not any outliers. So because to have an outlier, you have the IQR times 1.5 must be further away from the either Q1 or Q3 than 1.5 times the IQR. So this student did that here. 1.5 is 6 times. So the answer is no. So it's not, 10 is not an outlier, and neither obviously is 2. So there's no outliers. Okay, let's take a look at the histogram. So the histogram, if we go here, I'll scroll back down this. Your histogram should look like this. You should have, and it doesn't matter your bin size, so you should have it. We've got this student put the mode, M, and the mode, median, and the mean right there. And it just simply looks like this. You just have these bars here, 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 and it looks like you have, and then you have this lonely little bar right over here. And that's if you have bin sizes of 1. So yeah, so most of you did a nice job on your histograms. Again, the histogram has frequency down here, and then your values here. Okay. All right. Let me erase this because I'll probably come back to this in a minute. So let me erase this really quick, please. All right. So now let's go back up. And then I think the next one, and that was worth 2 points, by the way. So, and then your box plot should look like this. Remember, 10 was not an outlier. So some of you chose not to put that. And then you have, some of you messed up your Q1. So Q1 is just to the left, your Q1 is just to the right of your minimum, because the minimum was 2 and the Q1 was 2.1. All right, so let's go back, look at the points so far so you understand how I'm grading this. So the first one was worth 1 point. The second one was worth 1 point. The whole 5-number summary was worth 2 points. The IQR was worth 2 points. The explaining that there was no outliers is worth 2 points. and each one of the histogram and the box plot was worth 2 points. Is this data skewed? If so, which way and what? Right. So the best way to look at skewed data is look at your histogram. If you look at your histogram, you have more stuff over here. So this, you can see that you have like a tail. I think the word what we used in here was a tail. The tail is to the right, therefore the histogram is skewed to the right. Okay, pretty heavily skewed to the right also. So pretty obviously skewed to the right. And so we're going to call that 2 points for that. All right. What is the best measure of central tendency to use? Now, remember, the two measures of central tendency, guys, let me write this down. We're always going to either choose between we're always going to choose between the mean. The mean is always our first choice, or we're going to choose the median. Okay, so those are the two choices we're always going to use. The mean is always our go-to choice if the data is normal. If it's skewed data, then we want to use our median. Let me say that again. If the data is normal, then we want to use the mean. If it's skewed, we want to use the median. That's why we use the median. That's why the median is nice. So, and this student does a nice job of explaining it. I'll let you read it. I like the way they put that in their own words. But you can see, as we saw before, the data was skewed to the right. Whenever you have a skewed data, you want to use the median. So the median was the best choice. All right, number 10. Most of you got this. Pretty simple. What percentage of is between 25 and 45? Well, that's just this portion of the box right here. And remember, every box plot has 25% in the left whisker, we call it, 25% in this part of the box, 25% in this part of the box, and 25% of this box. It's broken into 4 equal segments. All right. All right. So now the next thing we're going to do is, this was just a hand cranking out. We used the, hopefully you had the, what do you call it? The standard deviation population formula on your card, and then I'll just let you see all the math. The big thing is you need to find the mean. Some of you missed it, but you didn't show your mean. And this student did a really nice job of showing their work. Even though they used the calculator, they showed their work nicely. And so remember, you're just taking each piece of data, subtracting it from the mean. So the first thing you have to do is get a correct mean, and this student wrote it out very nicely. And then you have to square that answer and square root, and you should come up with about 2.6 when you do that, when you use your population standard deviation. So look that up. That should be in your notes. I think we've talked about that multiple times, and we always want to use the population standard deviation. All right, the next one, the next page. Now we're on to, what do you call it? Desmos, or I also allowed the Delta Math graphing calculator. Find the population standard deviation. Guys, this was simply just a put it into a table or whatever and then grind it away. I'm not going to pull up Desmos right now, but you just had to put this data in and into a table, or I've never used the Delta Math, but you guys say that's a pretty good way to go too. And then you just crank it through there, and you should come up with you just use this guy right here, the STVEPP. So remember, we need to use the P. We talked about that, and you get 35.9 if you do it correctly. This one is interesting. You have to go through and you have to find your standard deviation. So this person found that their standard deviation is 22 points. Oh, excuse me. They found their mean, sorry, my bad, is 22.6. They also found that the standard deviation was 8.8. So how much of the population was within, what did they say? How much of the population was in one standard deviation, one population standard deviation? So all of these datas right here, and remember, all of this data is within one of the mean, because the mean is 22.5. So all of this is within one standard deviation of the mean, and you get 67.4 for that. Okay. So so the way it is, there's 86 pieces of data, and 58 of them out of the 86 were within that one standard deviation of the mean. Okay. So there we go from there. And remember, standard deviation was 8.8. So all of this data is less than 8.8. all of this data right here, I'll just kind of draw this, all of these data right here are within 8.8 standard deviations away from the mean. And now one thing is, remember, you're not just saying there's not just one 14, there's 12 14s, there's 12 18s, there's 19 21s, and there's 15 28s. And that will give you a total of 58 pieces of data that are within 8.8 units away from the mean. Okay. All right. The next one is, and that was worth 2 points, by the way. And then this one was kind of an interesting one. I'll just let you see their data. They just took they just took 26 minus 6, and we've done this on Delta Math. This came straight up off of a Delta Math problem. They just took they took 38 minus 26 and divided by 2 because it was halfway through there, and they got a standard deviation up. They got a mean of they got 6. So once they got 6, they found the average. So they just took 26 minus 6 is 20. 38 minus 18 is 20 also. So we just went from there. And that's how they got the mean of 20. Okay. Hopefully this solutions was helpful, and you will be able to get some more points off your test today. Have a great day. See you later. And come see me in 7th if you have any more detailed questions about it. If don't, I'm more than willing to ask in-person questions. But this saves you a lot of time and maybe saves you having to come over to my 7th period. But if you need to see me, absolutely do so. See you later.